2.0 Understanding the concept of algorithms and flowcharting. 2.1 Definition of an algorithm. An algorithm is a step-by-step set of well-defined instructions designed to solve a specific problem or perform a specific task. It is a finite and unambiguous sequence of operations that, when executed, leads to a desired outcome. 2.2 Features of an algorithm. A. Precision. Algorithms must be precise, providing clear and unambiguous instructions without ambiguity. B. Uniqueness. Each algorithm should have a unique solution for a specific problem. C. Effectiveness. Algorithms should be effective in achieving their intended goal or solving the problem. D. Finiteness. An algorithm should have a finite number of steps, meaning it should eventually terminate, not run indefinitely. 2.3 Methods of algorithm representation. A. English language. Algorithms can be represented in plain English with detailed step-by-step descriptions of the process. It is a natural language representation of the algorithm, making it easy for non-technical stakeholders to understand. B. Flowchart. A flowchart uses standardized symbols and shapes to represent each step or operation of an algorithm. Arrows connect these symbols to show the flow of control or data. C. Pseudocode. Pseudocode is a mix of natural language and simplified programming constructs that describe the algorithm's logic. It's less formal than actual code and is often used as an intermediate step before coding. Pseudocode is a way to represent the logic of a program using plain language and informal syntax. It's not tied to a specific programming language, but helps convey the structure and flow of a program. Here's an example of pseudocode for a simple task, calculating the sum of numbers in a list. 1. Start 2. Initialize a variable sum to 0, 3. Create a list of numbers to be summed, for example, 1, 2, 3, 4, 5, 4. For each number in the list, 4.1, add the current number to the sum 5. Display the value of the sum 6. N. This pseudocode outlines the steps for summing a list of numbers. It starts with initializing a sum variable to 0, then iterates through the list, adding each number to the sum. Finally, it displays the result. Keep in mind that pseudocode is not standardized and can vary in style. The key is to use a format that's clear and understandable for you and your team. D. Decision table. Decision tables are used to represent complex decision-making processes in algorithms. They list conditions and their corresponding actions, helping visualize different scenarios. E. Data flow diagram, DFD. DFDs represent how data flows within a system or between processes. They show how data is transformed and stored at various points in an algorithm or system. 2.4 Main ANSI flowcharts as algorithm representation. ANSI, American National Standards Institute, has standardized flowchart symbols for algorithm representation. Terminal indicates the start or end of the algorithm. Process represents a specific operation or computation. Decision represents a conditional statement where a decision is made based on a condition. Input-output signifies input from or output to external sources. Flowlines connect the symbols to show the sequence of operations. These ANSI flowchart symbols help maintain consistency and clarity when representing algorithms using flowcharts. 2.5 Drawing flowcharts for simple programming tasks. Let's illustrate simple programming tasks with flowcharts. Task 1. Calculate the sum of two numbers. Flowchart. A flowchart to calculate sum of two numbers. Start. Input A, input B, sum of B, output sum. Task 2. Check if a number is even or odd. Flowchart. Start. Input A to C. If remainder of C is 0, else output C is even, output C odd. End. 12. These are simplified examples to demonstrate how to create flowcharts for common programming tasks. More complex algorithms can be represented in a similar way, using a combination of symbols and connecting lines to depict the flow of logic and data. Questions and answers. Question 1. What is the purpose of using flowcharts to represent algorithms? Answer 1. Flowcharts are used to visually represent the steps of an algorithm, making it easier to understand, analyze, and communicate the logic of a process. Question 2. How can you represent a decision in a flowchart? Answer 2. Decisions in a flowchart are represented by a diamond-shaped symbol, where the condition is written inside, and arrows indicate the different paths based on the condition's result. Question 3. What is the significance of using pseudocode in algorithm development? Answer 3. Pseudocode serves as a bridge between natural language and actual code, allowing developers to outline the algorithm's logic in a more human-readable and abstract form before writing the actual code. Question 4. Which ANSI flowchart symbol is used to represent input and output operations in a flowchart? Answer 4. The ANSI flowchart symbols for input and output operations are represented by parallelogram shapes. Question 5. Describe the process symbol in an ANSI flowchart. Answer 5. The process symbol represents a specific operation or computation step in an algorithm. It can include arithmetic calculations, data manipulation, or any other task performed by the algorithm. Question 6. How does a data flow diagram, DFD, differ from a flowchart? Answer 6. A DFD focuses on illustrating how data flows within a system or between processes, while a flowchart primarily represents the sequence of operations or steps in an algorithm or process. Question 7. In a flowchart, what does the start symbol represent? Answer 7. The start symbol in a flowchart marks the beginning of the algorithm or process. Question 8. Can you explain the purpose of the terminal symbol in a flowchart? Answer 8. The terminal symbol in a flowchart indicates the end of the algorithm or process, showing where it terminates. Question 9. How can you represent a low OP to flowchart? Answer 9. A low OP can be represented in a flowchart using a curved arrow or a rectangle with the low OP condition inside, creating a low OP structure within the flowchart. Question 10. Why is it important to use standardized symbols and conventions when creating flowcharts? Answer 10. Standardized symbols and conventions in flowcharts ensure that the representation is universally understood and helps maintain consistency and clarity when sharing or documenting algorithms.